Okay guys, so I'd like to start by just reviewing some of the key theorems and properties of circles, and then we're going to build on by adding in lesson 10.5. Okay, so to start, we talked about tangents at the beginning of this chapter. If they share a common endpoint, as these two tangents do, so this tangent and this tangent, then what we can conclude is that the distance that I'm going to highlight right now from here to our point of tangency and here to this point of tangency, these are going to be congruent segments. Okay. The next thing we talked about were dealt with central angles. So this is key, and I think this is something a lot of people kind of get confused on or kind of pull out some of the details, and that leads, like I said, to some confusion. So a central angle means that you have to be working from the center. So this vertex has to occur at the center of the circle. As long as that happens, it's kind of like you're taking a piece of pizza out or a piece of the pie. As long as that's the case and the vertex is at the center, then whatever this angle is, let's say it's x degrees, then the measure of this corresponding arc is also going to be x degrees. Okay, so that's the relationship there. When we're dealing with a central angle, it's the same inside as it goes out because we have that point of continuity, which is that center point. That center of the circle is equidistant to every point on the circle. It's that we can draw in a million different radii. And so that's why the angle that's formed is equal to the measure of the arc as well. Okay. All right, because if we think about it like in a little circle here, this would be 360. Well, this is also a circle of the same value. So that's, if that helps a little bit. All right, moving on then. We talked about some chords. We said that this chord is, if we have two congruent chords, if that's the case, then we have two congruent arcs. And conversely, if we find that we have two congruent arcs, then we have two congruent chords. Okay, from there, we talked about whenever we have a diameter. Okay, so a diameter is drawn in. If it intersects a chord at a right angle, then what that creates are two congruent segments. It bisects. It doesn't only intersect the chord, but it bisects the chord. And then it also bisects that arc. So meaning that the two segments I'm going to or arcs I'm going to highlight, that arc and this arc are congruent. Okay. All right, next, a little bit more with chords. We learned another one that said that congruent chords are what we have if and only if that they're equidistant to the center. So again, working with our center point, if this distance to this distance here, and the way we can make sure that distance is equal, because you could make that whatever you want, but meaning, let's say, go back. Okay, so let's say that I draw in a segment here and it's 2 inches, and I want to draw another 2 inch. I can possibly do that, but the way we make sure we have two congruent segments is they has to be perpendicular to the other side. That means we're making a right angle. That's the shortest distance between, the shortest distance between any two things. Points is a straight line, meaning it forms a right angle. So same idea here. So if we have this, and this is our given case, then we have congruent chords as long as our two distances from the center are congruent. So if I can draw a segment from the center to one chord, the center to the other chord, each perpendicular to the chords, and these are congruent, then I can then conclude that my chord is congruent to this chord. Okay, and then from there that my arc is congruent to that arc, and it works the other way as well. Okay, all right, and then the last one that we added in was dealing with an angle, which is why I elaborated on this one. It's similar in style to the central angle, but in this case, we're not talking about the vertex being at the center of the circle. The vertex is instead on the side of the circle. So when this is the case, and our vertex is on the side of the circle, if this is x degrees, then this intercepted arc is double that. So this would be 2x. Okay? So 2x degrees, that is. All right, so that just summarizes what we've done. Now let's add on some new stuff, okay? So now here we are at lesson 10.5, and with having that brief review, if you need to go back at any of them, by all means, please do that. But we're going to start to add in some more, and I just want to make sure we were comfortable with what we had before we add too much to our plate. So this next theorem actually builds off of what I had just said. So we'll discuss that in a minute here, but let me read it. It says, if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of the intercepted arc. Okay, so this is actually super similar to what we just did. So before we said if we have an angle such as this, such that the vertex is on the outside of the circle, then we can conclude that the relationship with our angle measures, if this is x degrees, then this intercepted arc is going to be double that, 2x degrees, okay? Well, now we're doing the exact same thing, but instead of our vertex being on the circle looking like this, being formed by 2 chords, instead, we're going to find that it is formed, so let me draw another circle, because that picture to the right we'll look at, but I want to show you the relationship. We'll still have a chord, but then this other chord isn't in the circle. It's not really a chord at all. It's a tangent. Okay, so we still have our vertex on the outside of the circle. It's the same scenario as we had up here, which we did in the last lesson. It's just that now it's not formed by 2 chords. Now what we have is a tangent and a chord. So we have a chord here and a tangent here. But again, notice that point of intersection is still right on, the vertex of that angle is still right on the circle. Okay, and the ratio is the same thing. This is x degrees, and then this intercepted arc, which is actually this entire distance here, the entire thing all the way down to that point of tangency is 2x degrees. Okay, so let's look at the picture. So they're showing us here that angle 1 is this little angle in here. So it's formed by just like that. And that is going to be equal to 1/2 the measure of its intercepted arc, which is all of this. Okay, so if this is x degrees, this whole thing is 2x. Okay, now we can also work the other way, because if we have one angle formed like that, this is also another angle. It's formed by a chord and a tangent. So let's say this was y. Then this entire intercepted arc here is going to be double that, 2y. Okay, now they've written it a little bit of a different format with 1/2. It's the same thing. They're just saying that this angle, measure of angle 1 or 2, or x and y in my case, is 1/2 of what it said. So it's the same ratio. All right, so let's go ahead and apply it. Here we have a chord and a tangent, but the only thing I really have to keep in mind is that they intersect on the circle. Okay, it's the only thing that's different than central angles. It just intersects on the circle. So they're giving me the intercepted arc of 130. That means the measure of angle 1 is 1/2 of that. So it's going to be 65 degrees. Okay. In the second one, letter B, find the measure of the red arc, or angle or arc. They're giving me the angle. So that means my intercepted arc, this red portion, is double that. So the measure of arc KJL, and I put the arc above it, and it's 3 letters because it's a major arc, is going to be 125 times 2, or 250 degrees. Okay? Let's try a few more of those. Same concept. So find the measure of angle 1. This is my chord. This is my tangent. So this angle in here is going to be 1/2 of the arc that is intercepted. So 1/2 of 210, I can say that the measure of angle 1 is equal to 105 degrees. If I move on to number 2, they want the measure of arc, RST, so this entire arc right here. Okay, so if I do that, since I know that the angle itself is 98, I'm going to double it, and I can say the measure of arc, RST, is going to be 98 times 2, which is really 100 and, yeah, my brain stopped, 196, okay, degrees. All right, and then the last one is the measure of arc XY. So this is this right here. Since this is 80, my arc is going to be double, so measure of arc XY is going to be 160 degrees. Okay, I'd like to add in one more new concept, because this one kind of built on what we already knew. So the only officially new thing is this concept here, and we're going to kind of stop a little bit after we do the first part. So it's saying now that we've already looked at two lines, whether it be a chord, 2 chords, or whether they be a chord in a tangent, but nonetheless, and you could throw secant in there, but there's three ways they can intersect, and that's what we're talking about in this here. They can intersect right on the circle, like we have here. So this would be a scenario like we've already talked about. If this is my angle, if this is x, and this intercepted arc here is double that, 2x. So we've already talked about that scenario. Now there's going to be times where we have them intersecting inside the circle, and notice this is not the central angle. They did a good job of making clear that this is not intersecting right in the center of the circle. So they're intersecting at some random point inside the circle, or maybe they'll intersect at some random point outside the circle. So this is going to lead us to our two final things for this lesson. I'm just going to do the inside one for now though. Okay, so here's the ratio, the relationship when we have angles intersecting inside. So if two chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Oh my goodness. They do a good job. It's hard to explain math sometimes. Let's just talk about this. Okay, so I'm going to draw a circle over here to the left, sorry. And just kind of take it piece by piece. If I have two chords, okay, and they intersect, and again, a secant is just a chord that keeps going, so you could, that's where the pictures up above came from. You could do that. I think it's less confusing to have less on the screen. So this is what we have. Now if I call this angle 1, what I know is that this angle is congruent to that angle because they're vertical angles, right? Okay. All right, I'm going to put in the letters that they did over there on the right, A, B, C, D. And this is what the theorem says. The measure of angle 1, the measure of this angle right here, which is also the same as this one here for that matter, but the measure of angle 1, the way you find it is you add up DC, arc DC, plus arc AB, and then you take half of it. Okay, so we would do measure of arc DC plus the measure of arc AB, figure out whatever that comes to, and take half. Okay, and that's what this theorem says. And then they also do it for angle 2. So this is the measure of arc BC plus the measure of arc AD, and then you take half of it. Okay, so you just add them up and divide by 2. Essentially, you're finding the average. That's all you're doing there. Okay, all right, so if you could with me, turn the page. We're going to just try one or two of these. We'll do the intersection outside for the next lesson. Okay, so not to add too much. All right, so notice that they're intersecting inside the circle. So my formula is going to be that the measure, right, not even measure, I'm just going to write x degrees is going to be equal to 1/2 of the measure of arc KL plus the measure of arc JM. Now you don't have to write that, but I want you to see what we're saying. So I'm going to add up the two arcs that kind of have a relationship to the angle we're finding. Okay. Again, this is the angle we're finding, which is congruent to that because of the vertical angle congruence theorem. I add them up and divide by 2, so I take half the average. So 1/2 of KL is 156 and JM is 130. Okay, so that's 1/2 of 286. Which gives me an answer of 143 degrees. Okay, all right, let's move on. I think there's only one more I'd like to try, and that's this one right here, right below it. Here they want us to find the value of the variable, same idea, so they want this one. So what I know is that I can say that y plus 95, y degrees plus 95 degrees, if I take half of that, that should equal this angle right here. Well, they don't give me that angle directly, right? I know that this angle is equal to half of the two arcs that it intercepts. So this and this, half of the sum of those. Well, since they don't give me this angle, I will look to see is there enough info to figure it out. And actually there is. If this is 102, these angles are supplementary. So that means that this is 102. This here is going to be 78. So I can now say 78, because that's the measure of this angle right in there. 78 is equal to 1/2 of y plus 95. Okay, we're close to the end. So then I would multiply both sides by 2. So 2 times 78 is going to give me 156. And then I have y plus 95. I'd subtract 95 on both sides. So I find the value of y is going to be 61 degrees. Okay, good work. Try those out. Slow it down if you need to and revisit. Good work. Thanks, guys.